Hey guys, how's it going? Hope that everyone is doing all right now. You guys are staying safe during the pandemic right now. So just moving along in our trigonometry unit for Math 30. Um, if you're following along in my class, we are working through our chapter 6, which is trig identities. So I know that some other schools like that do the trig in a slightly different order and stuff like that. Guys, the content's all going to be the same, like that, that we're teaching and that you're going to be doing at your school as well. It's maybe done in a slightly different order. Okay. So the topic we're doing today is sum and difference and double angle identities. All right, so just a bit of review over here. Give an exact value for the following trig ratios. Okay, so quick unit circle here. We have 3 points here for 30, 60, and 45. And we have root 3 over 2, 1/2. We have root 2 over 2, root 2 over 2. And this last point is 1/2 comma root 3 over 2. So if we go sine 60, okay, so we're looking for the y coordinate on our unit circle at 60 degrees. So this answer is going to be square root of 3 over 2. If we're looking for cos 45, is the x value at 45 degrees. So it's going to be root 2 over 2. And cosine 30 degrees is going to be the x value on 30 degrees. So it's going to be, again, the answer of root 3 over 2. Okay, so we're just picking these values off our unit circle. Now, what we're looking at here is, well, we have 75 degrees, and unfortunately, 75 degrees is not on our unit circle. Okay, now, first thought for this question, okay, well, hopefully, well, not hopefully, guys, but something that you may recognize here is that 75 degrees is equal to cos 45 plus 30 degrees. Okay, so like this. Now, guys, I think the thing, and this is actually a wrong way to do this question, but I'm going to show you why this is not true as well. The first instinct I'd have for this question is to do cos 45 plus cos 30, which equals root 2 over 2 plus root 3 over 2. And guys, I'm just going to go on my calculator here, and I'm just going to figure out what this decimal is going to be. Okay, so my calculator, I'm going to go into degree mode, so mode degree, and then I'm going to go square root of 2 over 2 plus square root of 3 over 2, and this answer gives me 1.573 dot dot dot. Well, if I go cos of 75 degrees, hopefully, guys, we're seeing there's a bit of a problem already. So we learned already that a cosine ratio has to be in between -1 and +1. Well, already we're having a problem, okay, because this guy over here is 1.57, which is outside of our range, okay? And again, if I just fire my calculator and go cos 75, you get cos 75 equals 0.2588. Okay, so so what we have over here is not working. So the point I'm trying to make over here is that this, so sort of back up, this is equal, but cos of 45 plus 30 does not equal cos 45 plus cos 30. Okay, so in other words, the distributive property does not work here. This is not cosine times 45 plus 30, so you can't just distribute the cosine through. It's cosine of 45 plus 30. Okay, so the distributive property is not going to apply for a question like this. Okay, so now I guess the question is, what does cos of 45 plus 30, what does this equal to? Okay, guys, bear with me for a second. I'm just going to pull up my my formula sheets. All right, so back to our formula sheet. And guys, almost everything in this formula sheet is all trig, or at least over half of this formula sheet is trigonometry. Sorry, guys, just slow computer internet connection right now. All right, so what we're looking at over here is today's topic. Well, for this example, for sure, we're going to be looking at these identities right here, okay? And these are called our sum and difference identities for sine and cosine, okay? So I'm just going to come back over here and let's actually go ahead and go back to slideshow. So yeah, that's great. Okay, so what we have here is we have this identity, which is a cos A plus B. This is actually alpha plus beta, because I don't know, we use Greek letters for this stuff over here. Guys, I don't know why we use Greek letters like that. This is kind of just a common convention for this unit over here. We have cosine of A plus B. So what we have is, we have cos of A plus B, I'm just going to use A plus B instead, equals cos A, cos B, minus sine A, sine B. Okay. Now in this case, our A value is 45 and our B value is 30. Okay, so this is the sum 45 plus 30 is cos 75. Okay, so what we get is we get cos A, so cos 45 times cos B, which is cos 30, minus sine A, so it's going to be sine 45 times sine 30. Okay, now let's look at our exact values for 45 degrees and 30. We have root 2 over 2, root 2 over 2, and we have root 3 over 2, comma 1 half. Okay, so cos 45 is root 2 over 2, cosine 30 is root 3 over 2. Sine 45 is root 2 over 2 times 1 half. So what we get here, root 2 over 2 times root 3 over 2 is going to be square root of 6 over 4 minus root 2 over 4. Okay, now subtracting these two fractions, we already have a common denominator, so the denominator is going to be 4, and we get root 6 minus root 2 over 4. I'm just going to go ahead and do them in the calculator. I just want to confirm that this decimal should be the same thing as this decimal over here. Okay, so if we go, I'm just going to go bracket square root of 6 minus square root of 2 divided by 4, bracket divided by 4, and this indeed does equal 0.2588 dot dot dot. So these guys are in fact equal, okay? But this is the exact value for cosine of 75. Okay, example E. We have sine of 105 degrees. Okay, similar idea where we want to go sine of 45 plus 60. 45 plus 60 is 105. Now, the trick to these questions is you want to pick these two values. You want to be able to find two values that are on your unit circle that add to make this guy 105 over here. Okay, so back to our previous page, we're going to use the sine A plus B identity, which is this guy right here. Okay, so this is right on your formula sheet as well. So we have sine A plus B equals sine A cos B plus cos A sine B. Okay, so very similar to what we did in the last example. Okay, except now we're using 45 and 60 in a slightly different formula. Guys, we're going to see almost the exact same numbers, kind of different spots over here, but it's going to be very, very close. All right, so this is equal to sine 45 cos 60 plus cos 45 sine 60. All right, so sine 45 is root 2 over 2. Cos 60 is 1 half. Cos 45 is 45. It is root 2 over 2. Sine 60 is root 3 over 2 equals root 2 over 4 plus root 6 over 4 is root 2 plus root 6 over 4. And this is our answer for this guy over here. Okay? So this is our exact value for sine of 105 degrees. Okay. All right. So guys, hopefully you're following along so far. Let's go to cos pi over 12. Now here's my advice for pi over 12. Guys, if I just convert this into degrees, this question gets so much easier. Otherwise, you'd think, okay, well, which two fractions subtract to make pi over 12? And that's kind of a lot harder to do. But if I just convert this to degrees, well, I get 15 degrees. Okay, so this is the same thing as cos of 15 degrees, which is the same thing as cos of 60 minus 45. Okay, now, it's not the only way. I could have gone cos of 45 minus 30. That would have worked. I could have gone cos of 135 minus 120. I could have gone to, cos of 330 minus cos of 315. Okay, so a whole bunch of ways I could have done this question, but and all of them would work and kind of lead to the exact same answer. Okay, guys, we're going backwards to our formula sheet here. We're using our cos A minus B formula for this guy over here. Okay, so we get cos of A minus B equals cos A cos B plus sine A sine B equals cos 60 cos 45 plus sine 60 sine 45. Guys, for all the examples like this, they're all going to end up being almost the exact same numbers. The signs, positive or negative, might be slightly different, but it's going to be very, very similar. So we have 1/2 root 3 over 2, and that's for 60 degrees. And then we have root 2 over 2, and that's for 45 degrees. Okay, so kind of applying this to this question, we have cos 60 is 1/2. Cos 45 is root 2 over 2 plus sine sine 60 is root 3 over 2 times sine 45 is root 2 over 2. So we get root 2 over 4 plus root 6 over 4 equals square root of 2 plus square root of 6 all over 4. Okay, and this is equal to this exact value for this ratio over here. Same thing, also the same thing as this ratio over here, but whether you do it in degrees or radians, it's going to be no difference. But I think it's much easier to kind of convert the radians into degrees, and then the ratios aren't going to change if you're in degrees or in radians. Okay, it's much easier to do it this way. Okay. We have tan 30, tan 135, and tan 60. So hopefully, guys, off our unit circle, we're going to remember that at 30 degrees, we have root 3 over 2, 1/2. When we divide y over x, which is 10, we get 1 over root 3, or if we rationalize it, it ends up being root 3 over 3. For 45 degrees, we have root 2 over 2, root 2 over 2. Divide these guys by each other, and we get an answer of 1. For these two, we have 1/2 root 3 over 2. Divide these guys, we get root 3. Okay, so tan 30, root 3 over 3, tan 135 is negative 1, because it's going to be this guy over here, and we know that tan is negative in the s quadrant. Tan 60 is square root of 3. Okay, all right. We have tan of 7 pi over 12. So my first recommendation is let's figure out what is 7 pi over 12 times 180 over pi. Let's convert this into degrees. We do this and we get 105 degrees. So we get tan 105. Okay. Now a couple ways I could do this. Okay. So let's say option 1 is going to go tan of 60 plus 45. Option number 2 okay. Now, both of these ways are going to work for this question, guys. Okay, so whether you choose choose option A or option B, my recommendation is to do option A over here. Not because this is a plus, but because this is a 60 and this is a 30 over here. Okay, now here's why this is kind of relevant in a question like this. If you look at tan 60, we get this value, and tan 30, you get this value over here. Okay, now again, both are exact values, but in my opinion, this expression here is a simpler expression than this guy over here. Okay, so I mean, again, I think it's going to be, you're going to have more problems using this ratio than using this ratio over here. So for all of these questions you're going to have, and these are specifically for the tan sum or different identities, guys. If you have a choice of using a 60 or a 30, and guys, for all these questions, you will have that choice using a 60 or using a 60 or 30. Choose the 60 if you can. Okay. Here with you guys. Here. So going back to your formula sheets, we have a tan sum and different identities as well. So we have a tan A plus B and a tan A minus B formula here. So I'm just going to copy these into my notes over here. Okay. So using these guys, I'm going to use option A over here. And that means I'm going to use my tan A plus B formula. Okay. So tan A plus B, in this case, is going to be tan of 60 plus 45 equals tan A plus tan B. So it's going to be tan 60 plus tan 45. Okay. Over 1 minus tan A tan B. So 1 minus tan 60 tan 45. Okay. Now we know from our previous page over here that tan 60 equals the square root of 3 and that tan 45 equals 1. So we get root 3 plus 1 over 1 minus root 3 times 1. Okay. Now, guys, like we've been doing throughout this unit, is we have an irrational denominator here, and we want to be able to rationalize the denominator. Okay. Now, this is a bit of review from Math 20 here. I'm just going to rewrite this again. So this is what we have. In the bottom here, we have two terms. There's 1 minus root 3. Multiplying times square root of 3 over the square root of 3 is not going to work in this case, because if I do, well, I'd rationalize the second term, but then I'd unrationalize the first term over here. So we learned a process in Math 20, and it was called multiply by the conjugate. Okay, now the conjugate is, if this is 1 minus root 3, the conjugate is 1 plus root 3. So we want to multiply the top and the bottom by 1 plus root 3. Okay. Now, what that gives us, I'm going to expand my numerator out, and it gives me root 3 plus 3 plus 1 plus root 3 over 1 plus root 3 minus root 3 minus 3. Okay. Now, what you'll see happens is when you multiply, why multiplying by the conjugate works is you always get like this plus root 3 and then minus root 3. These middle terms always cancel out when you multiply by the conjugate. So you get, we have 2 root 3 plus 4. 1 minus 3 is negative 2. Okay. Now what I'm going to do is, since I have like coefficients here and here, I can divide each of these guys by -2. And this gives me an answer of -√3 minus 2. Okay. Now, just going under calculator here, I just want to verify that this decimal here gives me the same thing as this decimal over here. Okay. So I go negative square root of 3 minus 2. This equals negative 3.73 dot dot dot. And then if I go tan of 7 pi over 12, I'm just going to make sure that my calculator is now in radian mode. And so if I go tan 7 pi divided by 12, I do indeed get the exact same decimal, negative 3.73 dot 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 over here. Okay, so guys, this does not work over here. I would stop. This is my answer for this question. Stop at -√3 minus 2. I was kind of verifying that this gives me this decimal, this gives me this decimal over here, so they are in fact even equal over here. Okay, guys, for questions like this, before you write your quiz on this unit and before you write your unit final, you need to do about at least 4 or 5 of these type of questions. Okay, I can almost guarantee that a question like this will pop up on the unit final or in your quizzes, and that you will need to know how to do a question like this. They're tricky. Okay? It's tricky because you need to remember how to rationalize denominators. You need to be very good with your exact values for tan functions, and it just can be kind of tricky. Okay, sorry guys, back to my formula sheet here. So on our formula sheets, we have some more, and we're getting into the what we call the double angle identities. So I'm just going to copy these guys over here because we're going to be using them for the rest of the notes here. Okay, sorry guys, thanks. Okay, so what we have over here is we have a few more identities that we need to kind of get good at using over here. So, guys, there's a typo here. Please write in a 2 into your notes right there. There should be 1 minus 2 sine squared 67.5. Sorry about that, guys. Okay. So what we're doing over here is like what I said earlier on this unit, guys, is that anything on your formula sheet you are allowed to use for free. Okay, that means that you don't need to prove it for all the ones on your formula sheet, but so it's on a formula sheet, you are allowed to go and use you are allowed to go ahead and use those ones. So in this case, we want to say give exact values for 1 minus 2 sine squared 67.5. Okay, now 67.5 is not a value on our unit circle. Okay, but if we look at this guy over here, 1 minus 2 sine squared 67.5, we see something very, very similar to that right here. Okay, so what we're able to do here is we're allowed to make a replacement like this. Okay, so in other words, so cos 2a where in this case alpha is 67.5 degrees. So what this is equal to over here, this is equal to cosine of 2 times 67.5 degrees, which is cosine of 135 degrees. Okay. Now we have an exact value now for 135 degrees. At 135 degrees, that is this guy in our unit circle over here, and this x value is negative √2 over 2. Okay, so that's how this guy works. It's going to work over here. Let's take a look at example B. Okay, so for example B, we have 2 sine pi over 12 times cos pi over 12. If we see this guy over here, this is almost the exact same thing as this identity over here. So this is what we call a double angle identity for sine. Okay, so here 2 sine alpha cos alpha equals sine of 2 alpha. Okay, all right. So what's that going to equal in this case over here? We have where our alpha is pi over 12. So what we know based off this identity is that this expression can simplify down to sine of 2 times pi over 12. The 2 over 12 simplifies to pi over 6, which is sine of pi over 6. And pi over 6 on our unit circle is this value here, which is root 3 over 2, comma 1 half. So this exact value is 1 over 2. And that's our answer for this question over here. All right, so we're starting to get into some more proof type questions. Okay, so we use a lot of these identities in some of our in simplifying trig expressions or kind of proving trig identities. We're going to use these identities quite a bit. So what we have over here, we have 1 minus cos 2 theta over sine 2 theta, and we want to be able to make a simpler trig expression than this. Okay, so looking at this. Well, let's look at the bottom over here. We have a sine 2 alpha, or sine 2 theta, which is the same thing as like this identity over here. Okay, so sine 2 theta is the same thing as 2 sine theta cos theta. Okay, now in the numerator, cosine 2 theta questions are always going to be a little bit more tricky. And the reason is because we have 3 different identities for cosine 2 theta. Now what we have over here is we have 1 minus cosine 2 theta, okay? So hopefully what you're going to see is that this is the one that we're going to want to use, okay? So let me rewrite this over here. If I have cosine 2 alpha, same thing as 1 minus 2 sine squared alpha. Now why is this one going to be, I want to be able to make this look like 1 minus cos 2a over here. So the way I'm going to do that, if I have 1 over here and I have cos 2 theta over here. So if I subtract cos 2 alpha from both sides, and if I add 2 sine squared alpha to both sides, what I'm left with is 2 sine squared alpha equals 1 minus cos 2 alpha. Okay, so what I'm going to do now is I'm just going to do this replacement. I've modified my trig identity to equal 1 minus cos 2 alpha. So this is going to be going in for this guy. Now, in this equation, my variable is theta, not alpha. So I'm just going to make this guy a 2 sine squared theta. And now I'm able to do some cancellation here. I have a 2, the 2's cancel out, sine theta cancel with one of the squares on the top, and I'm left with sine theta over cosine theta, and that's the same thing as tan theta. Sound good? Okay. All right. Very similar example for example B. We have sine 2x over cos 2x plus 1. Guys, I'm just going to go ahead and erase, give myself a bit more room over here. Okay, so simplifying this expression, Guys, the double angle ones for sine are easy. There's only one option. So sine 2x is the same thing as 2 sine x cos x. Guys, it doesn't really matter what the variable is. I'm using an x in this example. I used a theta in this one. In your formula sheet, they use alphas instead. It is whatever your variable is. It doesn't matter. It's the same thing. Okay. Now, what we have here is we have a cos 2x plus 1. So looking at our three options for cos 2 alpha over here, I hope you'll see that we want to now use the middle option over here. Okay, so the middle option, I want to get a cos 2x plus 1. So if I go and add 1 to both sides, I get cos 2 alpha plus 1 equals 2 cosine squared of theta. Okay, so this equals, I'm going to make a replacement for cos 2x plus 1. I'm going to replace that with 2 cos squared, and we're left with 2 cos squared x. You guys are going to simplify to exactly the same thing. The 2's cancel out. The cos cancels out with this, and we're left with sine x over cos x, which is tan x. Okay. So, I mean, what we found over here is both of these expressions simplified to tan x. Okay. For example C, we have cos 4x cos x minus sine 4x sine x over here. So we have, we're going to be able to simplify this trig expression over here. And I included my sine, my addition and subtraction identities over here. So what we have here, we have cos minus sine, and that's the same thing as this one over here. It's cos minus sine. So this is equal to cos of 4x plus 1x, which is the same thing as cosine of 5x, because 4x plus 1x is 5x. Okay, so again, we're trying to get a more complex trig expression over here, simplified down into a simpler expression over here. Okay, we do this, guys. Is it just the in Math 31 in the trig equations for calculus, we'll have to be able to solve some very complex trig equations. And the reason why we're doing this is it gets much easier if you can kind of simplify a more complex trig equation into simpler trig equations like this. It's going to make your equations a lot easier to solve. Okay, and sometimes, guys, it's almost going to be impossible to solve it without using some identities first. So this guy, this is math to learn more math down the road, and it's going to be more helpful in some of your trig equations in your calculus course coming up. Okay, all right. So we have sine pi over 2 minus x. This is like a sine a minus b formula over here. So I'm just going to apply this guy over here. Pi over 2 is my a, x is my b value. So this is equal to sine pi over 2 cos x minus cos pi over 2 sine x. And at pi over 2 is the top of the circle. We have 0, 1. Okay, so sine pi over 2 is 1 times cos x minus cos pi over 2 is 0 times sine x. Is cos x minus 0 is just equals cosine of x over here. Okay, so in this case, sine pi over 2 minus x is the same thing as cosine of x. Okay, so again, I mean, this is one of those ones that kind of pops up more in Math 31. If you have an expression like this, which you will see from time to time, I mean, you can make this into a much simpler expression, which is going to be cosine of x instead of having to write out this guy over here. All right, example 4. The value of sine theta is -4/5. If angle theta is in quadrant 4, then what's the value of sine 2 theta? Okay, so for this question over here, sine 2 theta off our formula sheet is equal to 2 sine theta cosine theta. Okay, now we have sine theta. This answer is negative 4/5. What we don't have is cosine theta. Okay, so we need to just actually go back to our chapter 4 stuff for trig ratios to be able to solve and figure out what is cosine theta going to be. Okay, so we know that we're in quadrant 4. We don't really need to do this, but this is quadrant 1, 2, 3, and quadrant 4. Okay, so what this is telling us is that we have an angle in center position here, and here's our reference angle. So if sine is negative 4/5, that means this is our y, and this is our r. Okay? Remember, guys, radius is always going to be positive, but in this case, our y value is going to be negative 4. Okay. Now I'm going to use Pythagorean theorem to figure out what my value of x is. So x squared plus negative 4 squared equals 5 squared. Subtract 16 and square root. In this case, x is going to be a positive 3 because I'm in quadrant 4, so x is going to the right, so it's going to be positive 3. So based off this, cosine is x over r, so therefore cosine theta is 3/5. So this value of cosine theta is going to be replaced by 3/5. So what this answer is going to be is 2 times negative 4/5 times 3/5. This is 2/1. 2 times negative 4 is negative 8 times 3 is negative 24. 1 times 5 times 5 is 25. And this is my exact value for sine 2 theta in this case. Okay. Similar question, for example, 5. Sine A is 4/9, cos B is negative 1/2. What's the value of sine A minus B if angle A is in quadrant 2 and angle B is in quadrant 3? So, first of all, let's go figure out what angle B is. Sorry, let's do angle A first. Angle A is in quadrant 2. Now, what information do we have? Sine A is 4/9. This is y over r. So if I go 9 squared minus 4 squared, that's going to equal 81 minus 16, which is 65. That means this guy over here is going to be square root of 65, but it's going to be negative in here. So it's going to be negative root 65 because we're going to the left. So therefore, cosine of A is negative root 65 over 9. Okay, so there's our cosine A. A, we'll need that. Cos B, quadrant B, angle B is in quadrant 3. So if cosine B is negative 1/2, this is x over r. So 2, negative 1, 2 squared minus negative 1 squared is 4 minus 1, which is 3. That means this guy is going to be a negative square root of 3. Therefore, sine of B is negative root 3 over 2. Okay. And what we're asked for is sine A minus B. Sine A minus B equals sine A cos B minus cos A of sine B. And this is off our sine A minus B formula on our formula sheet. And we have values for sine A, sine B, cos A, cos B now. So sine A is 4/9. Cos B is negative 1/2 minus cosine A is negative root 65 over 9. Sine B is negative root 3 over 2 times negative root 3 over 2 is negative 4 over 18. Negative times negative is positive, but we still have this one over here, minus 65 times 3 is root 195 over 18. This answer is negative 4 minus root 195 all over 18. And that's going to be our answer for this beast over here. All right, guys. I hope that this is kind of making sense. Trickier topic over here, guys. But so make sure that you're keeping up to date with your homework stuff, this, guys. And please, as always, just send me a message or shoot me an email if you have any questions, or you can just talk to me in class about this stuff as well. Okay, guys. I will see you in the next video.